This is a bead. If you let it roll along a line of grass, that represents 1 hour. 2 strips of grass mean 2 hours. But if you wanted to show a whole day, you'd need a lot of grass, which is obviously inconvenient. So clever, you come up with a better idea. You take that long strip of grass and bend it into a circle, dividing it evenly into 12 sections and marking them with numbers. Now when the bead rolls to the 2, it represents 2 o'clock. Congratulations, you've just created the hour hand. But you want to show minutes too. So you divide the circle into 60 smaller sections and add another smaller bead. You set this bead to move 12 times faster than the first one. 1 full revolution per hour. That's your minute hand. Then you add an even smaller bead, the second hand, which moves 60 times faster than the minute hand. If you want to show 6:30, your hour hand points halfway between 6 and 7. The minute hand points to the 6, and the second hand glides a little past the first mark after 1. And there you have it, the clock face. But now comes the tricky question. How do you make these 3 hands rotate precisely at those speeds? Let's start with a small experiment. Imagine 3 gears, representing the second hand, minute hand, and hour hand. Suppose the second hand gear has 60 teeth, matching the 60 markings on the dial. When it turns once, the minute hand gear should move 1/60th of a turn, giving a gear ratio of 1 to 60. That means the minute hand gear would need 3,600 teeth, and since the hour hand turns 12 times slower than the minute hand, its gear would need 43,200 teeth. Obviously those gears would be enormous, far too big to fit inside a clock. But you, being the ingenious type, think of a workaround. Split the ratio across multiple smaller gears. Here's how you do it. Attach a 10-tooth pinion to the shaft of the second hand gear, and let it drive a 60-tooth gear, achieving a 1 to 6 ratio. Then mount an 8-tooth pinion on that gear and have it drive an 80-tooth gear, for another 1 to 10 ratio. Multiply them, and you get your 1 to 60 total ratio, perfectly translating the second hand's motion into the minute hand's slower turn. You repeat the same principle for the hour hand, combining a 1 to 3 and a 1 to 4 gear pair to make a 1 to 12 reduction. Now with these compact compound gear trains, all your hands move smoothly and precisely, and all the giant gears are replaced by small, efficient ones. Finally, you tuck the whole system neatly behind the dial, add a mainspring to power it, and congratulations, you've just invented the mechanical clock.